My goal for this project was to make the thief as unhappy as possible. I used a windshield washer pump to make a nice strong spray and actuated the button on an incredibly loud air horn using a servo motor. Before I jump into the details, let's see it in action. You know you can't trust those shady horse types. Here's my basic setup. I have an Arduino board switching an external 12-volt supply to the washer pump through an N-channel MOSFET. The pump has a flyback diode fitted between its leads and drains current from the MOSFET into the negative terminal of the battery. The board is also controlling a stepper motor through a stepper motor driver. The motor is used to trigger the air horn by rotating an eccentric lobe enough to press the button. Along with the 12-volt source, the board is using a 9-volt battery to avoid voltage sag when the pump starts up. The Arduino detects whether to trigger the traps based on the state of a reed switch, which is only closed when there is no magnetic field around it. There's a magnet hidden under a mat on the porch, so when the box is lifted away, the reed switch closes. This sends a high voltage to a digital pin on the board, telling it it's time to act. There's also a physical kill switch in line with the reed switch, which allows me to disable the system when setting it up or repairing it, which happens a lot. Like I said earlier, my water pumping solution was to use a spare windshield washer pump and tank assembly to make integration easier. I cut a length of tubing to fit the package, then designed and 3D printed a nozzle to get a good spray pattern. For this prototype, the nozzle is always exposed through a small hole in the corner, but in a future version, I'd like to make it a little more concealed. The pump draws too much power for the Arduino to supply on its own, so I ended up using a MOSFET and external 12-volt battery to keep the board from frying. And yes, building a spray device in the same box as exposed electronics was just as sketchy as it sounds. As for the air horn, getting the stepper motor to actually trigger it was somewhat of a hardship. The motor doesn't have enough torque on its own, so I had to come up with this lever system to create the force required. I had to 3D print some mounting points for the components, as well as an off-center lobe on the motor shaft that spins down to trigger the horn. I used that little stack of magnets to keep the lever attached to the motor. Let's see a quick demo. Watch your ears. Now, on to the code. Here's the setup, where I initialize the pin numbers for controlling the circuit, as well as setting the rotation speed and angle, or number of steps, for the stepper motor. The next piece is where all of the action happens. The main loop continuously checks for the switch pin to read high, which indicates there's no magnetic field and the kill switch isn't flipped. Once the pin goes high, a 3-second timer is set. At the end of the timer, a while loop will run for as long as the switch remains closed. In the while loop, the code cycles between spraying water from the nozzle and sounding the horn. If the switch goes low again, indicating the kill switch is flipped or the magnet is replaced, the code will go back to monitoring the switch pin and leave the traps turned off. Over the course of creating this, I've learned that there's a lot more going on in a simple device than it may seem, and that components can easily stop working if you use them incorrectly, or if they just feel like it. So now, a couple of outtakes.
Action!